So yeah, today's experiment is about light from atoms. So who is excited to learn about this new concept? Okay, that's good. That's good. That's good for me. So yeah, in this experiment, first you use a spectroscope. So if it's not calibrated, then you need to calibrate the spectroscope. I can show you how to do that. Then after that, you will observe the hydrogen lamp. So you will observe the hydrogen spectra with the spectroscope. So first we need to know some basic, why we see, something. Why you are seeing that table here? How do you see that table, or how do you see this thing, or how are you seeing me? Is it a silly question?
This reflects the light from our eyes and.
Okay, so yeah, you are very close. So actually, the atoms are absorbing light, and they are then emitting the light. So that emitted light is coming to our eye, and we're seeing that object. Okay, so like we are seeing colors, right? So like his T-shirt is orange, right? So why you are seeing that orange?
Frequency.
The rods and cones in the back of near your retina.
Okay, so that's the detector. Yeah, you're right about that. So, like, the light is coming to the detector. So, which light is coming? Like, the atom is absorbing the light and it's emitting certain part of it, not all of it. Okay, so that part is responsible for orange color. So you will see it here, like in an atom. So this is a typical atom. So this is the nucleus at the center, and these are like the energy levels. So very basic. So this is energy level 1, 2, 3. So when you shine light on an object, it absorbs that light, and the electron goes to the higher energy level. Okay. So you see that this atom is absorbing light and going to the higher energy level. So this is excited state. That means this state is not stable. Okay. So it will like to be in a stable state. So in that case, it will go down. The excited electron will go back. Will fall back to the stable state, which is the lower energy state. So this is an excited atom. It's emitting energy in the form of photon, and it's going back to the lower energy state, which is a stable state. Okay. So this light hitting your eye, and you are seeing that object. Okay. So this is the basic concept light from atoms. Okay. So I have a question for you. So assume there's light source, and you are staying here. So if I put something which is, you see green, like any glass which is green, okay? So which light is passing through that green glass? Green, right? Yeah, just the green. That's why you are seeing the glass as green, because only the green light is hitting your eye. So if I put a red glass, there is the light source, and then the green filter, and then I put the red filter, like red glass, then which light will you see?
Green and red.
So green filter is allowing only green light, right? And what will do the red filter? So green filter is blocking all the lights and only allowing the green light, right? And there is the red filter. So it will block all the light and only allow the red light to pass, right? So that means you will not see any light, because the green filter filtered out all the lights, and the green light then hit the red filter, but the red filter will not allow the green light to pass, right? It will block that. So that's the kind of basic concept. So this is the atomic spectra of hydrogen. So you are using the hydrogen lamp. So yeah, it's a light source. So this light source is fluorescent. So our sun has like different frequencies. So yeah, we only see the visible part of the light. Okay, not all of them. So okay, so hydrogen lamp has these different frequencies of light, like in ultraviolet region, visible region, and infrared region. So we only see the visible part of light. okay? So infrared radiation is basically a heat radiation, like we cannot see, but we feel it, right? If you're cooking, you feel the heat, right? So the heat is basically the infrared radiation, infrared light, which we cannot see, but we can feel it. So I mean, you have seen some movies like where the commandos use some gadget at night to see things like the night vision, like things. So that's the infrared vision, okay? So it allows you to see the infrared light. So infrared is basically heat, so any source which produces the heat, they can see that. Like our body produces heat by the combustion reaction, right? So that's why you can see human being, but if something is cold, which is not producing light, you cannot see with the infrared vision, okay? So that allows you to see in like the other shoulders or something like that, okay? So today you are going to see only the visible light because you don't have any infrared gadget to see the infrared light. So with the spectroscope, you will only see the visible light. So you see that these are different series. So you can differentiate like the Lyman series, Balmer series, and Paschen series by seeing the energy state where all the excited atoms are going. Like for the Lyman series, all the excited electrons are going to the first energy level. And for the Balmer series, it's going to the second energy level, and for the Paschen series, it's going to the third energy level, okay? So you cannot see these two, so we'll not talk about that. You will only see the visible portion of that hydrogen light. Okay, so at this point, do you have any questions regarding to this? Okay, so I think you understand everything so far. So now I'll go to the spectra. Okay, so before going to the spectra, in nature you see a spectra. Can anyone say that? What's that? I mean, in nature. So spectra is basically like, so either say the light has different component. Okay, so if you separate those components, you'll see different colors. Like visible light has 7 different colors. Probably you know that, right? Blue, blue, yellow, orange, then violet, red, yellow. So 7 different color, right? So if you use a spectroscope, it will separate those components into different parts, right? So do you see in nature that spectra?
Rainbow.
Yeah, that's correct. So you said in rainbow. So how do you see that? I mean, how do you see the rainbow? How the rainbow forms? Any idea?
Sunlight reflecting into the water.
Yeah, so it related to water, right? So basically you see it after the rain or sometime like that. So it's related to water. So what does the water do? What's the role of the water in that part?
Breaks the light.
Yeah, you're right. You're absolutely right. So it's actually acting as a prism or diffracting grating. So those are like hard terms, so I'll not talk about them. So it's like the separator, okay? It separates the light into individual components by refraction. So in your spectroscope, you have that water, so which is the prism here, okay? It acts as the water, it separates the light. So this is your hydrogen lamp, and the light goes through the spectroscope. These are the different parts, please. So the prism is the most important part, which separates the light into its individual component. So it separates them into, so the hydrogen lamp has these 4 visible part of light, which is violet, blue, green, and red. So you will see using the spectroscope, and since this is calibrated, you can measure their wavelength, okay? So from that wavelength, then you can calculate the energy and you can draw the energy level diagram. So this is the calculation part, which I will not talk about. So if you have any problem or concern, you can ask me after the class. And then after calculating the energy level, you have to draw the energy level diagram here. So the diagram is basically showing the transition, okay? So you see the transition here, the excited electron going back to the ground state. So you show the transition here in this part, okay? From which level the electrons are coming to the ground state. So you can see it's n equals to 2 for the Balmer series, okay? Because the Balmer series is n equals to 2, so it's fixed, okay? Okay, so any questions so far about the experiment? What's my
We
time?
got one more minute.
Okay, so no more questions? Okay, so if you don't have any question, then I guess you can start your experiment.